This is Module 10. We're continuing in our exploration. Be sure to watch the first video. So at the end of the last video, we said if this random assignment method works, then it should be the case that we get approximately 2/3 males in the elevating group, and we should expect approximately 2/3 males in the lowering strategy group. So what does that mean to get 2/3? It means we expect maybe 7, 8, 9 males out of 12, maybe even as far as 6, 7, 8, 9, 10 males in a group. What we're going to do now is we're going to actually explore the distribution to see what it is we should expect. So there is a Rossmann-Chance applet. Let's go straight to that. So here in the Rossmann-Chance applet collection, you see on the top right, there is the applet Randomizing Subjects. I'm going to click on that. What we find here in the randomizing subjects is they have already taken the 24 names, the 24 subjects. Remember, there were 16 males, 8 females. They've already made a group 1 and a group 2. And we have a randomize option here, and it's already selected that we're considering gender, sex. I'm going to hit randomize once. What's happening on the right here is that it's acting like it's shuffling cards with each of those 24 names on it. It then randomly selects 12 names to go in group 1 and randomly selects 12 names to go in group 2. So it did it once. And over here in group 1, you see it picked Michael, Matt, Alice, Roger, etc. Group 2 has Marvin, Mary, Patrick, Anna, etc. So I'm not concerned about the actual names in each group. What we're asking is, what proportion of males are in group 1 and what is the proportion of males in group 2? And that's given to us at the bottom. It says here group 1, when we did the random assignment of people to groups, had 58% males, and that left group 2 with 75% males. Remember, we were expecting about 2/3 male in group 1 and about 2/3 male in group 2. That would be 60.6666667, so 66.7% males in each group. We didn't get that. We didn't get that exactly. We got 58% and 75%. So what we're going to do is we're going to look at a distribution down here at the bottom that displays the difference in the two groups. So down here, we have a point plotted on our dot plot, and this point is negative 0.167. To find that value, it took the proportion of males in group 1, which is 0.5833, minus the proportion of males in group 2, 0.75, and it got this negative 0.167, right? If it had been the case that group 1 and group 2 both had exactly 2/3 male, then when it's subtracted, it would have done 2/3 minus 2/3, and it would have been 0, and it would have put a dot above the 0. That didn't happen this time. It was a little lower than 0, because group 1 had fewer proportion of males, a smaller proportion of males than group 2. I'm going to hit randomize again. We're going to reshuffle the cards and make group 1 and group 2 all over again. So it's shuffle, shuffle, shuffling. It's reassigning group 1 and group 2. All right, this time it put 50% males in group 1 and 83% males in group 2. You subtract, and it plots a point down here. If I shuffle again, I get 50% males in group 1, 83% in group 2, so I get a second dot. This time, on my fourth attempt, I got 2/3 males in the first group, 2/3 males in the second group, and so you see a dot appear above 0. Okay, I'm going to turn animate off so it stops showing us the cards, and I'm just going to hit randomize a bunch more times. So every time I hit randomize, it's shuffling the cards and assigning group 1 and group 2 people randomly. Instead of hitting dots one at a time, I could go ahead and do like 100 repetitions. I could do 1,000 repetitions. There we go. So I've now done more than 1,000 repetitions of creating these groups using a random assignment method. You see what happens, like usual in this class. We are getting a distribution that's roughly bell-shaped. This distribution is centered at 0. You see there were a lot of occurrences where it made the two groups, and group 1 had 2/3 males, and group 2 also had 2/3 males, and thus you would get a dot at 0. I'm going to make a screenshot of this. Okay, so now I've brought this screenshot back here to our lecture guide, and let's just kind of explore what we can see from that distribution that was created. So when we have a result at 0, when it put a dot at 0, it meant group 1 had 2/3 males, means 8 males out of 12. And it also means group 2 had 8 males out of 12. It was 2/3 in each group. So when we had a result that was in one of this, the bar to the right of that, it meant group 1 had 9 males out of 12, and so group 2 had 1 fewer, 7 out of 12. And on the other side, if there was a dot over here on the left bar from the middle, that was the opposite. There were 7 males out of 12 in group 1 and 9 out of 12 in group 2. And one more will do. So here is 10 males out of 12. Thus, this one would be 6 males out of 12. And here is the 6 males out of 12 and 10 males out of 12 in group 2. So this and this were unusual. They're in the tail. They're not occurring very often. And beyond that, is certainly unusual. They never occurred. So it seems to me that what we found was when we created these random groups over and over and over and over by just shuffling and like drawing from a hat, you can expect to see between 6 males out of 12 in a group up to 10 males out of 12 in a group. It never turned out to be the case that we did randomization of groups and all of group 1 was completely male. So that just never happened. It seems like we got pretty close to having 2/3 males in each group. But again, we don't expect exactly that, but it is pretty well balanced. Number 7 and 8 are further just walking through the directions of how to use that applet. So I'm just going to skip up here to number 9. Number 9 is asking, does random assignment always distribute or balance the men and women between the two groups equally? No. We do not get exactly balanced groups of 2/3 males in each group. But what we did see is that it was close. There was a similar proportion of males in each group when we used random assignment. So why do I care about this? When we used random assignment to create the groups, we got approximate balance of gender, sex in the two groups. We like that because that means that gender, sex, would no longer be a confounding variable. Okay, so that's good. We did find then when we used random assignment, it did seem to balance out the proportion of males and females in the group. So at the end of the day, if we found like the elevating group did better, then we couldn't say that it was because group 1 had a higher proportion of males in it or because they had a higher proportion of females in it. It couldn't be that way because they had approximately equal balance of males and females in the two groups.